Alright, subtopic number 2, which is on charging and discharging of capacitors. So in this subtopic, you have to be able to state the physical meaning of time constant and use the equation of time constant. And then sketch and explain the characteristics of charge against time and current against time graph for charging and discharging of a capacitor. And lastly, use these two equations here. So one is for discharging, this one is for charging. Wait, is that, I'm not sure if the charging punya equation is correct. Increases, I feel like I did something wrong, but I'm not sure. So yes, okay, that one is correct. For this one is discharging, this is charging. But my graph here, oh, betul lah, charging, discharging, and one of it is terbalik, just the graph. But I'll fix it before I upload it lah, macam biasa. Okay, so we have two processes that a capacitor can undergo, which is charging and discharging lah. So how do you charge capacitor to a resistor is basically when you turn on the switch, which is when you close the switch, like what you did in today's experiment, the current immediately begins to flow through the circuit. So some of you get 90 microamperes, some of you dapat 60, some of you dapat 48. So that is basically your maximum current lah. So what happens is electrons will then start to flow from the negative terminal of the battery here and begin to accumulate on the plate B here, okay? So electrons will then start to flow into the positive terminal of the battery through the resistor, leaving positive charges on plate A, okay? So sekarang ni kita ada net positive charge on plate A, net negative charge on plate B lah. So electrons then will be still pass through the resistor and onto the positive terminal, okay? So as the charge starts to accumulate on the capacitor, the potential difference across the circuit will increase and the current will reduce, okay? So what happened is eventually the maximum voltage across the capacitor will be equal to the voltage supplied by the battery here. Okay, so when these two voltage sudah equal, no current will start to flow through the resistor and the charge on the capacitor will increase gradually until it reaches a maximum value in which we call Q0. Okay, so itu apa yang berlaku time kamu charge the capacitor when the switch is closed. Right, after that, untuk discharging pula, so when switch S is closed, electrons masih lagi close kah? Wait okay, masih lagi. So when the switch is closed tapi there's no power supply lah, there's no what do we call that, battery, there's no battery now, okay? So when the switch is closed, electrons from plate B here will begin to flow through the resistor and neutralize the positive charge at plate B. Okay, so the potential difference across the capacitor sekarang ni adalah at a maximum, which is V0 lah, what have been supplied before. Bila dia sudah tiada battery pun, tapi dia masih lagi ada the V0, and then the maximum current will flow through the resistor. Lepas tu, when part of the positive charge on plate A is neutralized by the electrons yang berjalan ni, yang bergerak ni, the voltage across the capacitor will then start to reduce, okay? Dia sudah start to reduce sebab dia tidak sudah kena supply. So, mestilah dia akan berkurang. So, the process continues until the current through the resistor is 0. That's why time kamu buat tu, kamu sudah start discharge dia akan bergerak slow, and then makin lama makin slow, okay? So dia punya process tu is not a very quick punya process, unless yang ada one part of it is just a bit faster lah than the lowest current yang hujung-hujung satu, okay? When it's about to get 0. So at this moment, all the charges at plate A ni is fully neutralized lah. Lepas tu the voltage across the capacitor, will then becomes 0. So that is what's happening when you discharge the capacitor. Okay, so the graph pula ini adalah basically the graph of charge against time for charging, and this one is for discharging. Okay, so untuk charging, the time constant, we will get the time constant at 63% of the maximum charge. Okay, dari situ kamu akan dapat the time constant. So the time constant is equal to RC lah. Okay, so untuk discharging pula, it is just up to 37% of the maximum charge. Okay, so untuk charging basically 63%, untuk discharging dia 37% lah, macam tu. And then this one is actually salah. It should be, bukan salah the graph, this thing salah, my equation is wrong. It shouldn't have this one. It should be just like that, but I'll fix it before I'll upload it lah. So basically what the graph here is telling us is the charge on the capacitor will increase with time. So if you can see, dia akan increase with time lah. Lepas tu untuk the potential difference across the capacitor will also increase with time, but the current going through the resistor will decrease exponentially with time. Untuk discharging pula, the charge on the capacitor will decrease with time, and as well as the the potential difference across the capacitor will also decreases exponentially with time, and then the current would also decreases. The current going through the resistor would also decrease exponentially with time lah. So basically untuk discharging semua decrease, untuk charging only the charge and the potential difference will increase, except for the current flowing through the resistor would decrease. Okay, so that's about it for charging and discharging. What you need to know is it's just basically these two part of the theory lah. Okay, so the calculation part is this bit here. Time constant, which is with the symbol tau, is basically the quantity of the product of resistor times the capacitance that appears in the exponent for all equations in the charging and discharging process is what we call as time constant. Okay, if that is too confusing, the formula is just this. Okay, so time constant is directly proportional to the resistor as well as the capacitance. So kalau the resistor is higher, the time constant would be higher as well, similar to capacitance juga lah. Kalau dia tinggi, the time constant pun tinggi. Macam tu. Okay, so it is a scalar quantity and has the SI unit of seconds, and then it is basically a measure of how quickly the capacitor charge ataupun discharge. So itu kamu lebih mudah faham lah. Dia just bagi tahu laju ke tidak dia charge, or discharge. Okay, besar juga. So it is a measure of how quickly the capacitor charge or discharge. So the physical meaning for time constant untuk charging is during charging, tau is defined as the time required for the capacitor to reach 0.63 ataupun 63% of its maximum charge. So itu adalah time constant punya definition untuk charging. Cara dia determine laju ke tidak dia charge. Untuk discharging pula, it is defined as the time required for the charge on the capacitor to decrease to 37% of its initial value. Okay, so that is discharging, the definition of time constant for discharging. Okay, right, so that is for time constant. Now let's look at example number 3. So this is an RC circuit. The battery has been fully charged by the the battery has fully charged the capacitor. At time t equal to 0 seconds, a switch S is thrown from position A to B. So maksudnya dia from position A to B. So dari sini dia pergi sini begini. Okay, so sekarang ni the battery voltage is 12 volt, capacitance is 3 microfarad. The current is observed to decrease to 0.45 of its initial value in 60 microseconds. So we have to determine the value of R, and then the time constant, the value of Q on the capacitor at t equal to 0 and at t equal to 100 microseconds. So let us just extract what we know. We know that the maximum voltage is 12 volt, and then capacitance is given as 3 microfarad. The current decrease 0.45 of its initial value in 60 microseconds. Okay, so for question A, the value of R can be calculated by applying the equation of current for discharging process. So why is it a discharging process? Because kalau kita tengok sekarang ni, this is a closed circuit. Kalau kita letak macam ni, dia open circuit lah. Sebab di sini tiada connection. So macam mana dia mau connect pergi sebelah? Dia ada putus di sini. Macam tu lah. Okay. So sekarang ni, this is a discharging process lah. So we are gonna use I equal to I naught E negative T over RC. Kenapa tidak guna Q? Kenapa tidak guna V? Because we only have the information of current yang kita boleh apply dalam this equation. Okay? Dalam this situation. So I is 0.45 I naught, this is I naught, this is E negative 60 negative 6, and then R is 12, V is salah, R is what we are looking for, this is 12. Okay, so we are gonna take ln on both sides. So this is gonna be ln 0.45. Oh, I forgot to cancel I naught. So ln 45, ln E negative 60, 10 negative 6, 12 R. C lah. Sorry, everybody. It's not volt, it's asking about C. C is 3 micro. So that is 3 negative 6 R. And then this is 3 negative 6 R as well. Okay, so ln E is equal to 1. So it's gonna be negative 60 times 10 negative 6 over 3 times 10 negative 6 R. Okay, so kira ni kamu akan dapat 25 ohm as the value of resistor. Okay, next kita perlu cari the time constant. So the time constant punya formula is straightforward, which is T equal to RC lah, tau equal to RC. So we have the value of R already, we have the value of C. So kita just substitute lah. So kamu akan dapat the answer to be equal to 7.5 times 10 negative 5 seconds. Okay, so that is the time constant. Untuk question C pula, it is asking about the value of Q on the capacitor at T equal to 0. So this one we are going to apply the equation of charge untuk discharging process. So that is Q naught E negative T over RC lah. So the T is equal to 0. So our equation, oh sorry, that is a bit too fast. Let me just redo that. Okay, so we are going to use the the charge punya equation for discharging process. However, we do not have any information on Q naught, but we do have the information on capacitance and V naught. So this is, we know that Q naught is equal to CV naught. So kita boleh masukkanlah dalam di formula here. So dia jadi CV naught equal to E to the power of negative T over RC. And we know that T here is equal to 0, so this whole thing is actually going to be equal to, this will be equal to 0, and E to the power of negative 0 will be equal to 1, okay? So, kamu akan dapat, can I just write as 1? So, basically, you will get, this gonna be equal to 1 lah, okay? Alright, so sekarang kamu boleh substitute sudah lah. C is 3, 10, negative 6. V is equal to 12, which will give you the charge at T equal to 0 to be equal to 3.6 times 10, negative 5 coulomb. Okay, so that is the value of charge lah. Soalan last pula, the value of Q at T equal 100 microseconds. You just have to use the same equation. So it's gonna be Q CV naught E negative T over RC. However, T sekarang bukan equal to 0, dia ada value. So kamu akan substitute lah. C is 3. This is 12. This is E. 100 negative 6. So the value of R is 25. C is 3 negative 6. Okay, so dari sini kamu akan dapat jawaban 9.49 times 10 negative 6 coulomb. Okay, so again, the final answer here I have is not my calculation. This is based on the reference that I am looking right now. But I'm just gonna double check to see if this is giving us the same answer ataupun tidak, because I'm not sure. Negative 6, and then RC 25, 3 negative 6, 9.489. Okay, so yeah, so this is the correct answer lah. Okay, so this is the solution for example number 3, where we apply some of the equations for discharging lah. But for charging process, it's basically just the same steps, just use different equations lah. Okay. Yeah, so this is for subtopic number 2.